All right, hey Algebra 1, we are talking today about the final method of solving systems of equations, which is the elimination method. This should be the third one you have in your notes, and you can write down at the top of this page, the elimination method is adding or subtracting two equations together to cancel out a variable. So this doesn't work perfectly every single time, depending on how your equation is set up. Fraction coefficients can make this tricky, but when it's set up correctly, this can be a really efficient and helpful method. So the example here is a great example of a time that we would use the elimination method, and what you'll notice here is that our y values are the same. One is negative, one is positive, which is helpful, but when we have the same coefficient, the same number of y's in our equation, we are set up perfectly for the elimination method. Now, the one thing that's nice about the elimination method is that you don't have to manipulate your equations to set them up in a y equals mx plus b form. You don't have to solve for x or y. What you can do is just stack them up with x's over top x's, y's over top y's, and constants over top of constants. What we're allowed to do with equations like this is add them or subtract them if it's set up correctly, but in this example, we're going to add them. And the reason we're going to do that is because I have a negative 2y and I have a positive 2y. And if I combine those two things together, I have 0 y's left. If I combine my x's, 4x plus 1x, I have 5x. Add my 7 plus 3, which is 10. And I already have found out here, based on just eliminating my y's, that x is going to be equal to 2. Now I'm able to plug this back in, just like we've done with some prior substitution equations. So I'm going to choose this second one just because it has a single x. Plug this back in, 2 plus 2y equals 3. I'm going to subtract 2 from both sides and end up with 2y equal to 1 and y equal to 1/2. So the solution to this system is 2, 1/2. Nice and easy, super quick, because I noticed, hey, I've got the same number of y's, so I can eliminate those by adding or subtracting. All right, so let's look at another example here. In this example, you can see that the x's are set up to be eliminated, but what you might see here is that they are both positive. So adding here isn't going to help us because we'd end up with 8x. So instead, in this example, we're going to subtract our equations. And by doing that, it eliminates 4x minus 4x, that's 0x. So those are eliminated. You can start to see why this is called the elimination method. When I subtract 9y minus 6y, I get 3y. Now, it's important to notice, remember, these signs, our plus or our minus sign, get lumped in with whatever term is right after it. So if this was minus 9y, we would have to think about subtracting negative 9, so make sure that you're keeping your positive and negative signs straight. But in this scenario, they are both positive, so we just do 9 minus 6. That gives us 3y. Then we have 1 minus negative 2. So this is an example where we have to think about those signs. So 1 minus a negative 2 is a positive 3. Divide both of these by 3, and I have found that y is equal to 1. Now I can plug this back in to one of my equations. Again, this doesn't really matter which one you plug it into because you can plug it into either one. Just like when we substituted, you can plug it back in. Sometimes with substitution, we like to make sure we plug it into the equation that we haven't manipulated at all. But in this scenario, you can plug it into either one. It doesn't matter. I'm going to go ahead and plug it into, let's plug it into the first one. So we've got 4x plus 9, y is 1, equals 1. So I have 4x plus 9 equals 1. Subtract 9 from both sides. 4x is the same as negative 8, and I'm going to solve to find x equal to negative 2. So my solution to this system of equations is negative 2, 1. And I've done that just by eliminating one of my variables. All right, if you need to pause and make sure that your notes are all caught up here, feel free to do that. we're going to go on to our next example, which is one like this. This is where things get a little bit trickier because you'll notice my x's and my y's don't match. So I have to figure out a way to get these in a scenario where they match and can be eliminated. You can choose either your x's or your y's. It doesn't matter. And all we're looking for is a common multiple, something that I could turn both of these into, which would allow me to eliminate. So I'm going to go ahead and let's do the x's. So I know 3 and 5 both go into 15. So what I'm going to do to set this up for elimination is take my entire first equation times 5 and my entire second equation times 3. This will set me up for elimination because my first equation is going to turn into 15x plus 35y equals 75. My second equation is going to turn into 15x plus 6y equals negative 12. Now you can see that I'm all set up to eliminate. So this is a scenario where we might have to do kind of one extra step in our setup to make sure we're good to go. So you can see here my 15s match. They're both positive, so I'm going to subtract them to get rid of them. So there are 0 x's left. 35, positive 35 minus positive 6 is a positive 29. And 75 minus negative 12 is a positive 87. When I divide by 29, I end up with a positive 3. Now I can go back and plug this into either one of my original equations. Let's just plug it into the second one. So I've got 5x plus 2 times 3 equals negative 4. I'm going to subtract 6 from both sides to find 5x equal to negative 10, which shows me that x is going to be negative 2. So my solution to this system of equations is negative 2 comma 3. So again, this is an example of where that elimination method requires a little bit extra on the setup. All right, let's do one more example. We probably have time for 2 more here. Let's do 2 more examples. All right, now, on this example, you may notice right off the bat, we don't have everything on the same sides of the equations. We've got things kind of jumbled around. So you have some options here. You can either take this 2y and not sure why my pen is glitching out. Sorry, there we go. Take this 2y and move it over here so that it matches this format. Or we can take this negative 3y and move it over here so that we've got this format. I would recommend the second example, what I just showed you, because we end up with x's and y's on one side and our constants on the other, what we call standard form. I think that makes things a little bit cleaner. So what I'm going to do is add 3y to both sides here so that my second equation is now 3x plus 3y equals 9. So now that I've done that, I can kind of ignore this piece. So these are my 2 equations. For my system, I've just made one little move so that they look the same. They're in the same format. Now I need to make sure that my x's or my y's match so that I can eliminate. So I'm going to go ahead and make the y's match, and I know 2 and 3 both go into 6. So I'm going to take this whole equation times 3. I'm going to take this whole equation times 2. So my new equations are 12x plus 6y equals 24, and 6x plus 6y equals 18. Now my y's match, so I can subtract them. So I know 12x minus 6x is 6x. 6y minus 6y is nothing, so those are eliminated. 24 minus 18 is 6. So when I divide here, I find x equal to 1. Now I can plug these back in. I would recommend plugging it into the equation you didn't manipulate, just in case you've made a mistake there. So when I plug this back in, 4 times 1 plus 2y equals 8. I'm going to subtract that 4 from both sides, so I have 2y equal to 4, or y equal to 2. So the solution to this system is 1, 2. All right, let's do one more example. And here's what I'm going to ask you to do. On this final example, pause the video, start this problem on your own, and see what kind of trouble you run into, and then start the video again and take a look at how to solve it. All right, so go ahead and pause, try this in your notebook, and then come on back. All right, so with this equation, we are set up with 2x and negative 2x. Those are opposites, so I'm going to add these together because 2x plus negative 2x eliminates my x's. So that gives me 0x. Then I have negative y plus positive y, which also eliminates. Gives me 0y. And then on the right side, I've got 3 plus negative 3, which gives me 0. So I end up at the end of this with 0 equal to 0. This is a true statement. And we know if we get all the way to the end and everything's eliminated and what's left is true, that means our answer is all real numbers or infinite solutions to that equation. Now I want to back this up for a second and think about this in a different way. What if, instead of being equal to 3 up here, what if this equation was equal to, I don't know, 7? Okay. Now, when I go ahead and go to eliminate this, I end up with 0x plus 0y equals 4, and it gives me a final answer of 0 equal to 4. This statement is not true. And what we know from our previous solving is that when we end up with a statement at the end that's not true, our answer is no solution. So that's kind of how it could play out in one of those special cases when we're eliminating. If we end up with a true statement at the end, we know it's all real numbers. If we end up with an untrue statement at the end with our variables gone, we know that means no solution. So similar to problems yesterday, where if we get all the way to the end, everything's gone, we just need to look and see, is that statement a true statement or a false statement, and that can dictate our answers. All right, so those are your notes for today with some examples. You're going to have the rest of the time today to work through some practice problems. This will be homework due tomorrow, and your problems are here, page 359, 1 through 23. You're just going to look at the odds. The answers to these odd number questions in the back of the book are on page R51 in the textbook if you want to check your answers as you work. Otherwise, I think this video ended up just under 15 minutes, so that should leave you about 20 to 25 minutes to work through these problems. You can work alone or with a partner, and we will answer any questions that you have and take a look at these tomorrow. All right. The rest of the time is yours. Use it wisely, and good luck.